Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about irrotational vectors. What is irrotational vector? An irrotational vector is a concept from vector calculus and fluid dynamics. In essence, it describes a vector field where the curl of the vector field is 0 at every point. In mathematical terms, for a vector field f, it is a curl denoted by del cross f is identically 0, then f is said to be irrotational. Properties of irrotational vectors. Zero curl. The defining property of irrotational vectors is that their curl is 0 everywhere in the domain. Mathematically, this is expressed as del cross f equal to 0. Path independence. Irrotational vector fields are path independent. This property is closely related to the concept of conservative vector fields. Conservation of energy. The path independence of irrotational vector fields implies the conservation of energy along any path within the vector field. Scalar potential. Irrotational vector fields can be expressed as the gradient of a scalar function known as the scalar potential. Mathematically, f equal to del dot v. Examples of irrotational vectors in fluid motion, wind patterns and magnetic fields. Fluid motion. The flow of an inviscid incompressible fluid around a stationary sphere at low Reynolds numbers is an example of an irrotational flow. The velocity field around the sphere is irrotational away from the surface. Wind patterns. Large scale atmospheric flow. On large scales, the wind patterns in the Earth's atmosphere can often be modeled as irrotational. Magnetic fields. Static magnetic field. In electrostatistics and magnetostatics, the magnetic field produced by a static distribution of magnetic sources. Magnetic fields in certain materials. In some materials, such as superconductors, at certain temperatures, the magnetic field can behave as if it is irrotational due to the expulsion of the magnetic flux. Visualization of irrotational vectors in 2D, 3D and flow visualization. 2D vector field. In a 2D vector field, you can create a vector plot where each vector represents the magnitude and direction of the vector field at a specific point. For an irrotational vector field, the vectors should align nicely without any springling or rotating patterns. 3D vector field. In a 3D vector field, you can use arrows to represent the vectors at various points in space. Similar to the 2D case, an irrotational vector field will have arrows pointing in smooth non-curling patterns throughout the space. Flow visualization. One common method is to release particles into the flow and trace their paths over the time. Relationship between irrotational vector and conservative vector fields. Mathematical connection. Irrotational vector is del cross f equal to 0. Conservative vector fields. And conservative vector field is one that can expressed as the gradient of scalar function known as the scalar potential. Mathematically, for a vector field f, this is expressed as f equal to del dot p. Scalar potential. Both irrotational vectors and conservative vectors fields are characterized by the existence of a scalar potential. Physical interpretation. In physics, both concepts have important interpretations. Irrotational vectors are often associated with flow without springing motion. Applications of irrotational vectors in physics. Fluid dynamics. Irrotational vector fields are extensively used in the study of ideal fluid flow. Electromagnetism. In electrostatics, electric fields generated by static charge distributions are often irrotational. Magnetostatics. Similarly, magnetic fields produced by steady currents or permanent magnets can be irrotational. Gravitational fields. In Newton gravity, gravitational fields generated by mass distributions can be considered irrotational. Heat conduction. In heat conduction problems, the temperature gradient within a material can be represented by an irrotational vector field. This property helps in analyzing heat transfer process in solids and fluid and optimizing thermal magnetic systems in engineering applications. Thank you.